Hello ladies, gents, and everyone's. It is Thursday, June 2nd, and we're here to talk about this week's space and astronomy news. Dirt on the moon isn't really dirt, it's something called regolith, that is basically pulverized rock bits ranging in size from, a centimeter down to incredibly fine dust particles. It definitely makes you wonder if plants could even grow in lunar soil at all. Well, a team of scientists has done just that. Yes, they grew actual plants in actual lunar regolith. Their study was published recently in Communications Biology, and they used samples from the Apollo missions to grow a plant called Thale cress, which they chose because it already has a very well-known gene structure. They put the seeds in the regolith, and the seeds went on to germinate and then grow into plants. Well, this is great news for the potential for using in situ lunar regolith as a growth substrate for plants. But okay, it's not quite that smooth sailing because they did find that the growth of the plants wasn't, great. The plants developed very slowly and they showed a lot of signs of stress. And the scientists actually measured this stress via looking at different gene expressions of the plants. The scientists found hundreds of differentially expressed genes that are associated with ionic stresses from things like salts, metals, and reactive oxygen species. So yes, plants can be grown in lunar regolith, but it will take some work to make that an actually good growth environment. Artemis I was on the launch pad back in April to do its big wet dress rehearsal test, which unfortunately had to be scrubbed due to a leak in the liquid hydrogen system. Now we know that the rocket has been repaired and it's going back to 39B on June 6th in order to do that wet dress rehearsal test again as soon as June 19th. During its time in the VAB, the rocket received various repairs, including that leak in the tail service mast umbilical and repairs to the helium system of the ICPS. The off-site gaseous nitrogen supplier also upgraded their system to meet requirements for the test. This wet dress rehearsal test will include loading propellant into the rocket's tanks, conducting a full launch countdown, and demonstrating the ability to recycle the countdown clock. This is the final test that Artemis I has to do before it can launch, which is now expected no earlier than August. NASA's MAVEN mission has been in orbit around Mars since 2014, exploring the planet's upper atmosphere, ionosphere, and interactions with the sun and solar wind. It's obviously well beyond its initial one-year planned mission and actually has its 5th extended mission. But back in February, the orbiter entered safe mode due to an issue with its IMUs. IMUs are inertial measurement units, and they're used to track the spacecraft's attitude. No, not how MAVEN is feeling, but rather its orientation. Now, the MAVEN team had already known that the IMUs were showing signs of aging, and they were actually already working on a potential fix, all-stellar navigation. That is, the spacecraft would be able to determine its orientation solely from looking at and identifying stars. But that fix wasn't ready yet when this happened in February, so the team had to go into overdrive and really accelerate their plan to get this all-stellar navigation up and working before the backup IMU linked to the backup computer finally failed, which they're expecting to happen maybe by October. Working under this intense time pressure, the team was actually able to complete that software patch back in April. The new software had to be uplinked to the orbiter, then it had to be tested completely, then the instruments had to be powered back on and configured, but now finally, as of May 28th, MAVEN has returned to full science operations using its new all-stellar navigation. And so the science around Mars continues thanks to the great effort by the team here on Earth. Apophis is a large near-Earth asteroid that is set to have a very close, but not dangerous, passage with Earth in 2029. Well, the International Planetary Defense Community used Apophis's most recent close Earth passages to do an operational exercise. The exercise spanned 18 countries and 4 months back in late 2020, early 2021, and the results were just published this week in the Planetary Science Journal. The exercise was coordinated by the International Asteroid Warning Network and NASA's Planetary Defense Coordination Office. Basically, Apophis was removed from the database of known near-Earth asteroids to see if it would be detected and tracked by the planetary defense systems that we have in place, simulating our ability to detect a potentially new hazardous asteroid. While there were some lessons learned and some suggestions for future improvements, overall the exercise was a resounding success. Given the potential consequences of a large Earth impact, even though it's a very, very unlikely event, it's one we really have to be prepared for. So exercises like these are really important, and it's great to know that we would at least have a heads up. Uranus and Neptune, the two ice giants of our solar system, are remarkably similar, including in their atmospheric compositions. Methane absorption in their atmospheres is what causes these planets to appear blue. But given that they have similar amounts of methane, it's been a puzzle as to why they are not the same color blue, as you can very clearly see in this image, which compares the two planets directly with correct size and color from Voyager 2 images. Or for a more technical view, scientists look at the planet's spectra, that is the brightness of light at various wavelengths, which as you can see are quite similar, but not exactly the same. But we may finally have an answer. A study published last week in the Journal of Geophysical Research Planets suggests that the cause of the color difference is haze. Haze refers to solid particles that are suspended in a planet's atmosphere. And in this model, both Uranus and Neptune have haze layers in their atmospheres. However, Uranus's is thicker. And because the haze reflects light in a way that kind of appears white, having this thicker haze layer on Uranus makes it appear a paler shade of blue than the dark blue of Neptune. Now, why Uranus has this thicker layer is less clear. The paper suggests that it could be because Neptune has a more dynamic atmosphere where methane condenses and snows out more easily, leading it to have a thinner haze layer. Their model is really exciting because it can consistently explain both planets' spectra across a range of wavelengths. But keep in mind that this is one solution to what is a very difficult problem. As the paper says, we are trying to find a haze/cloud structure of unknown constituents, of unknown size, and unknown complex refractive index spectra, using as our main probe of vertical level the absorption spectra of gaseous methane, which also has unknown systematic errors. So there's still a lot more to be done here, but luckily we know that Uranus is the top priority for future planetary exploration missions, so hopefully we will continue to learn more about the ice giants and why they are the way they are. Lastly, a really quick but exciting JWST update. NASA announced yesterday that the first full images from JWST will be released on July 12th. We do not know yet exactly what these will be images of, but NASA says they've been chosen to highlight the science themes that inspired the mission. The early universe, the evolution of galaxies, the life cycle of stars, and other worlds. Also, funny story, I went to their website right away when they made this announcement and it said July 12th, 2021. They fixed it pretty quickly, but just a nice reminder that we're all just humans doing our best here. And JWST really is one of humanity's best achievements so far, and I just absolutely cannot wait to see what it's going to show us about the universe. 40 days! Also, I'm going to officially become a doctor and receive my diploma this weekend. I got my robe and my silly hat and everything ready to go. So excited. That is all I have for you this week. Thank you so much for watching, and I will see you again next week. Have a good one. Bye!